With if-else-if structures, we've seen how we can use simple if-else statements to handle more complex decision-making. Now we'll look at how we can nest decision statements within one another to make what we'll call hierarchical decisions, which are situations in which we make one initial decision and then a series of decisions based on that. An example of this that I often use is deciding what to eat. You might start by first selecting a restaurant. And once you've done that, then you can look at the specific options for your food. The food decision is based on which restaurant you pick. We can implement this kind of logic in coding by nesting if statements, which just means putting an if statement inside of another if statement. I want to point out, as is often the case in programming, there can be different ways to solve the same problem. We'll see some other ways we can implement these hierarchical or layered decisions, but this is a good one for beginners. And I think certain approaches just make more sense to some people, so I like to show you lots of different ways to solve problems. When I was a college student, the Rolling Stones came through Colorado on a tour. I had always wanted to see them in concert, and they were really old, so I jumped at the chance to see them while I still could. Well, that was about 30 years ago, and it turns out I got to see them a few more times, and then I stopped bothering to go when they went on tour because I had seen them enough. Those guys just never stopped. But eventually it really will be the last time you get to see them play. So we're going to write a program that determines the ticket prices for a Rolling Stones show. The price will first be based on what level of the arena we're in, with the lower bowl being more expensive than the upper. Based on that, we can then determine the exact price by looking at what row we're in, with the closer rows costing more than if we sit farther back. I'm starting out with some basic user interface code already written. You can download this starter file from the link in the description, or you can just pause here and type it up. We're going to start by asking the user if they want lower or upper bowl, which is the variable section letter. And then we'll get the row number. Those will be used to determine seat price, and you can see that we output that using a console.writeLine statement. The extra spacing at lines 30 to 32 is where our decision logic will go. Let's start by running this and make sure the UI is working at least. I'll put in my first test case, and it outputs the price as -$1, since that's what I initialized that variable to. Alright, so the interface works. Now we're ready to jump in and start developing our logic. The first layer of the decision is which section of the arena we're going to sit in. Here's my usual reminder to use two equal symbols to make a comparison, since that's so easy to forget. We should focus on one little piece at a time, so I'm really just trying to pass my first test case right now, and I'll set the price to $100. Let's run that and try that test case. And that passed. It output what I expected. So now I'll move on and try my next test case, which is a lowercase l and row 4. This test case fails, but the way it fails is important. I was expecting it to say that the seat was $100, since at this point that's what it calculates for all lower bowl seats. But it says -1. That tells me that this if statement is evaluating to false and not executing the code block. My if statement is case sensitive, so it only works if the user types in an uppercase L. There are multiple ways to address this, but one easy way is to just convert that section letter variable to uppercase when I make the comparison. The string data type has a method called toUpper that does that for us. It doesn't matter in this program, but be aware that it's not permanently changing the variable to all uppercase. This toUpper method is returning an uppercase version of the string and leaving the original unchanged. So let's try it out with a lowercase l, but still row 4, kind of a modification of our first test case. That works, so my first test case passes whether I use uppercase or lowercase. My next test is lower bowl, row 15, and that ticket should be $75, since it's beyond the first 5 rows. Now, my logic isn't taking into account the row number, so I'm getting $100 instead of $75. That's the second layer in this hierarchy of decisions. What's the row number? So once I'm inside this code block for the lower bowl seats, I'm just going to add another if statement to check the row number. This is called a nested if statement because it's inside another one. That $100 price is for the first 5 rows. So my logic here is if the row number is less than or equal to 5, the price is 100. Otherwise, the price is 75, and else is the programming word for otherwise. So I'll just add an else block for that. Okay, so here's what that leaves us with. First, we'll check to see if the user selected the lower bowl. If they did, we'll then take a look at the row number. If it's row 5 or less, the seat price is $100. Otherwise, it's $75. I'll run this and input my first 2 test cases. Those both look good. Now I can work on the logic if the user wants the upper bowl. I'll look at my first if statement, which we might call the outer if statement, the one that checks the section. I'll tack on an else if that checks to see if they entered a U. And just to show another option, I'll address case sensitivity by converting it to lowercase this time. This works the same way as converting it to uppercase, I just have to remember which one I'm doing. And now within that upper bowl, I'm once again going to check the row number. If it's less than or equal to 5 here, it's a little cheaper than it was in the lower bowl because we're up higher now. So the seat price here is $65. And incidentally, I could have completely different logic here. Maybe the first 20 rows are the same, or maybe it's not even based on a row. Maybe it's based on whether you have obstructed view or something like that. But to keep it simple, we're just going to stick with row number. And on that note, just like in the lower bowl, I'll use an else statement to set the price for all other rows to $50. When I run this, I'm still going to go through all my test cases just to make sure I didn't break something that was working before. And now I'll proceed to test cases for the upper bowl. Those all look good, and it leaves just one remaining test case. What happens if the user enters something that's invalid for the section number? The price comes back as -$1 because none of the if statements are executing. I don't have one that addresses a user typing in X or something like that. My test case indicates that it should output invalid entry. This is another case where there are going to be a couple different ways we could handle it. One way I like to show, just because you might not have thought of it, is to just check if the seat price has been set to something other than my default of -1. So if the seat price is greater than 0, it means I've set the price to something valid, and I'll want to display this output that we've been using all along. If that's not true, then it doesn't have a valid price. So here's where I can output my invalid entry. Let's go ahead and test that out. And again, I'll start with a valid entry just to make sure I haven't broke something that was working. And now that last test case. Everything looks good. As long as we're talking about invalid entry, I'll point out one flaw in our program. That seat number is an int, so the user input gets converted from a string. If the user types in something that can't be converted to an integer, the program is going to crash. The fancy name for this kind of crash is an exception. And when this happens, most IDEs will do what Visual Studio has done here. It'll pause program execution so I can check out what happened. Later on, we're going to learn how to use this pause state to help us with our debugging. But for now, I just want to go up to the top and hit the stop button to halt program execution completely. That way I can move on with a clean slate when I run the program again. For now, we just have to live with an exception if the user types in something like that for seat number, since we haven't learned how to handle it gracefully. And since we can't really address that, that means our program is pretty much done. As I mentioned, we'll see some other ways to write logic that does this kind of hierarchical or nested decision making, but this is a simple strategy that I think will probably feel natural to a lot of beginning programmers.